So here is the recap.
Sir, I think the live session has started, so we
Okay.
can start.
So from yesterday session, what we know is for inequations, we will have usually more than one solution. That means we get some kind of range for as our solution, not a single value that we usually get in equations kind of world where two things are equal. These are unequal, we'll usually get a range. And the other thing which I will ask kind of to keep in always my mind is make sure once you get to understand what is this range, this is satisfying all the constraints that are provided in the problem. Okay, so like in yesterday's age problem, one of the solution was less than 10 years. Okay, so age cannot be negative, so the real answer was 0 to 9 years kind of thing, right? So that was something which we learned yesterday, that for inequations we usually have more than one solutions, and there are conditions which we need to make sure they're satisfied. Now I'll try to take this on number line. Okay, so these are very small I should say basics for inequality, and I don't want to list them down here. So what I'm going to ask is, let's try them and come up with those rules that we should always remember while trying to solve these inequalities. Okay, so get a pen and paper with you. I hope you already have one. How many of you have? Do you all have
Yes, sir. I'm
pen
ready.
and paper?
Yes, sir.
Okay, so let's draw 3 and 5 on number line. Create a number line and draw 3 and 5 on this number line. Let me also have a Jamboard and see. So let me create a new Jamboard. Okay, so you are able to draw 3 and 5, right? Let's not be worried about my bad drawing. Okay. If we have, let's say, 0 somewhere, this is kind of what 3 and 5 look like, right?
Yes, sir.
Yes.
So seeing two numbers, they are two integers, right? But it can be real number, anything, right? Now number line can represent all these kind of numbers. How do you decide which one is greater and which one is smaller on number line?
Sir,
It's
the
hard.
object which is to the right of another number is greater, and the object which is to the left is smaller.
Okay. Yes. So that's pretty simple on a number line. Things which are on the right side are greater, and things which are on the left side is smaller. Okay. Now, what we'll do is we'll do some operations on these two numbers. So right now I'm calling them 3 and 5. They could as well be any two numbers, A and B, in general, right? And when I put them on number line like this, what this says is if B is on the right hand side compared to A, that means B is greater than A. Correct? So now, if we had just a single, okay, so there are only three options that we can have between two numbers. They can either be on the same location, That means they are equal. One can be on the right of the other. That means if B is on the right, B is greater, or B can be on the left side of A. That means B is smaller than A. Right? When we have two numbers, that's the only possibility that can be there. Either they are all equal, or A is bigger, or B is bigger. A is on the right hand side, B is on the right hand side, right? There cannot be any other possibilities. So most of the questions which are there in this slide, we'll need to answer the relationship as which is greater and which is smaller. And what we are going to do is we are going to do the operations. So first operation is addition. Let's say if we add a number to 3 and 5, what will be the relation between them now, the new numbers? So let's take a number. Let's take a number, let's say 7, and add it. So what will be the new results we get?
10 and 12.
Okay, so we get 10 and 12. And what is the relationship between these two?
Sir, 10 is lesser than 12 by two units.
Okay, so 10 is less than 12, right? That means when we add, so if we generalize this, if A is less than B and C is any positive number, then A plus C will be less than B plus C. Can we say this?
Yes, sir.
For all values of C?
Yes, sir.
What about C when C is negative? Ishita?
Yes, sir.
Can we say this equation holds even when C is negative?
No.
No. So that means instead of 7, if we are doing -7, this will not be holding, right? What will be the new numbers formed? So let's try that. So I'll sorry, Control C. So now say add -7. What will the numbers we get?
-4.
-4 and
-2.
-2. Okay. So what is the relationship between these two numbers now? -4 and -2. How should we say?
-2 is greater than -4.
I think the relationship still holds, right?
Yes.
Okay. So whether C is positive or negative does not matter. We added 7, this was true. We added -7, it is still true.
Yes, sir.
Okay. So if we are adding the same number, then it does not matter if that number is positive or negative. Okay. That means even for subtraction, the same condition will hold, right?
Yes, sir.
Yes.
A minus C will be less than B minus C. How about multiplication? So let's just
Yes,
put
sir.
this
I
as,
think the relationship will still hold true.
you think this relationship will still hold true. I'll remove the example and I'll leave this in generic format. Okay, so let's try this. Let's multiply by -2. What will we get? The two numbers.
-6 and -10.
Minus, okay, instead of negative number, let's multiply by 2 first. So 6 and 10. Okay. So 6 is less than 10, right? So can we say that if A is less than B and C is a positive number, AC is less than BC? Can we say that?
Yes, sir, but only for positive numbers will it work, because if we take -2, it will be -6 and -10. So,
Multiply by -2, it becomes -6 and -10. And if you go to the number line, what we'll find is -10 goes on the left hand side and -6 remains on the right hand side. Whereas when these number positive numbers, these were like this, correct?
yes, sir.
So this was less than this. Now it is opposite. So this is less than this, correct? So now what is the result? If A is less than B and C is a negative number, then AC is more than AB. Can you say that?
Yes, sir.
Okay. How about division?
Sir, say the it will hold true only if C is a positive number.
Okay, so division by a positive number will maintain the inequality, just like the multiplication by a positive number. Let's give it a try. What should we try? Let's divide by 2, right?
Yes, sir. So it will be 1.5 and 2.5.
So 3 by 2 and 5 by 2. So we know 3 by 2 is less than 5 by 2. So if A is less than B and C is a positive number, then A by C is less than B by C. What about negative number? How should we?
So if we take by -2, then it will be -1.5 and -2.5.
So
So
which will
it will
be
not hold.
larger now? Which one is greater in these two?
Sir, -1.5 is greater than -2.5.
Is it right, everyone? Let's maybe clear this. So if we talk about -3 by 2, where does -5 by 2 lie? On the left or on the right?
Left.
So is this okay with all? Manan, Ishta, Shaurya?
Yes.
Yes, sir.
Okay. So you agree that -5 by 2 is less than -3 by 2. Okay. So if we divide by -2, so that means C is a negative number, then A by C will now become more than A by B by C. That means when we multiply or divide by a negative number, the equality sign changes from less than to greater than and vice versa. Correct?
Yes, sir.
Okay, great. So you are all with me so far. How about inversion? What do you mean by inversion? That means if A was more than B, what is the relationship between 1 by A and 1 by B? So 1 by 3 in this case and 1 by 5. How do I larger? Okay. Uh, oh, oh, I need to write as well. So how can I reduce it? So 1 by 3 and 1 by 5, which one is larger?
Sir, 1/3.
1 by 3 is larger, right? So A was less than B, 1 by A will be more than 1 by B. It is not right.
Sir, like we could do, so we will get 5/15 and 3/50.
Right. Or yes, so it can become 5 by 15 and 3 by 15. Just for sake of understanding why we are saying which one is larger. So can I write if A is less than B, then 1 upon A is going to be more than 1 upon B.
Sir, but only if it is. Sir, but if A and B are negative, then.
When A and B are positive. Let's take this case now.
Huh.
Okay. We'll take the other case as well. When these are negative, are both positive. Correct? So when these are both negative, that means let's take two example, -3 and -5. So A equal to -3, B equal to -5. Which one is smaller? Which one is bigger?
Sir, minus 3 greater than -5.
So let's say if A equal to -3 and B equal to -5, that means if A is greater than, so we are always thinking about less than, so let's talk it as yeah, A is greater than B. In this case, A is greater than B. In that case, how about 1 by 3, -1 by 3 and -1 by 5? Which one is larger, which one is smaller?
Sir, so we will get minus 5/15 and minus 3/15.
Yes, so which one is larger, which is smaller?
Sir, minus 3/15 is greater. Yes, minus 3/15 is greater than minus 5/15.
So in other words, we'll make them, means -3 by 15 and -5/15, right?
Sir, you have wrote minus 5/13.
Oh, sorry, thanks. So this is just an example, and now we are trying to generalize this. If A is more than B and A, B are negative, then 1 by A and 1 by, what is the relation? Which one is larger?
Sir, 1/B is
by
larger than 1/.
Like this? So -5/15 is larger than -3/15. Correct?
Uh, Sir,
Let's
minus
let's let's draw this. It's easier when we draw this, right? So let's draw this, where we will have -1 by 3. So let's say this is 0 and this is 1. This will be -1 by 3. Correct? And will be -1 by 5 right here, isn't it? तो कौन बड़ा है? 1 by 5 is more than minus 1 by 3. When? What was the relation between minus 3 and minus 5? Minus 3 was somewhere here and minus 5 was somewhere there, right?
Yes.
ये उल्टा मैंने लिख दिया, sorry. Let me erase this. How can this be? It's always in this way only. So this relationship and this relationship are still same. If minus 5 was less than minus 3, minus 1 by 3 is less than minus 1 by 5, isn't it? Is it right? That means whether the A and B are positive or negative, this relation still holds. The condition of positive negative is not there. Okay? Let's confirm that minus 5 is more than minus 3. 1 by 3 will be on this side. 1 by 5 will be on this side. Right. Is this okay to all? Can we say that as the conclusion?
Sir, I could not hear you. What did you say?
What I'm saying is whether A and B are positive or negative, the relationship if A is more than B, then 1 by A will be more than 1 by B. There is no inversion. Here, also it's the same. If A was less than B, 1 by A was more than 1 by B. And here if there is something which then seems to be right here because I'm using.
Sir, 1 by A is greater than 1 by B. It is right.
Yeah, no, this is right. So when both are negative, when you invert them, the order will not be changed. But when they are positive, when we invert them, the order changed. So if A was less than B, 1 by A became more than 1 by B. When they were negative, if A was more than B, 1 by A became more than 1 by B. It's not reverted here. Is it right?
Yes.
So let's once again understand on the number line. Let me clear this again and let's draw both 3 and 5. So when we inverted them, they became like this. This was 1 by 3 and this was 1 by 5. So this was the relationship. 5 became first, 1 by 5 became first, 1 by 3 became later. Right? In case of negative numbers, so 0 is somewhere here and minus 3 is here, minus 5 is here. When it came here, 1 by 3 minus 1 by 3 and minus 1 by 5. Okay, so five which was on the left earlier now is on the right, and 3 is on the left, right, this 3 on the right. Same here. So it is going to change. You see this? 5 which was on the right here came on the left. Okay. So if A is more than B, so this is A and this is B. A is more than B. Or let's talk about what A is less than B. If we call this is A and this is B, then 1 by A will be more than 1 by B. So this was A less than B. 1 by A becomes more than 1 by B. Here also, this was A. No. Since we want to retain this statement, we'll call the left one as A. So what we are saying here, this is A and this is B. So here, this becomes 1 by A and this becomes 1 by B. So when A is less than B, 1 by A becomes more than 1 by B. When we invert, the relationship also inverts. Got it? No matter it's positive or negative.
Yes.
Yes, sir.
This is clear?
Yes.
So if A is less than B, then 1 by A will be more than 1 by B. It does not depend whether A is positive. A and B are both positive or both negative. But they both should be of the same sign. That's a must. Okay. How about negation when we add a negative to a number? So I will leave on. Okay, since I've not lived. So if A is more than B, A is less than B, what will be the difference between minus A and minus B? Who will be larger? Now,
Sir, minus A will be greater than minus B.
this is just like multiplication by a negative number. We are multiplying by minus 1. What happens when we multiply with negative number? The sign changes. The less than sign will change to greater than sign, and vice versa. So when A is less than B, minus A must be more than minus B. Okay.
Yes, sir.
So let's write down if A is less than B, then minus A is more than minus B. Anyone knows about exponentiation here?
Sir, yes.
What is exponentiation?
Sir, the power of the number.
Okay, good. The indices that we take. So if A is more than B, what will be the relationship between n raised to A? What happened? N raised to A and n raised to B. You understand this notation, or should I make them subscripts and superscripts?
No, sir, it's understandable.
Do you know about this?
Sir, n raised to A will also be lesser than n raised to B.
Okay, that is when A less than B.
Sorry, yes, right.
Is this okay to all? Let's take the example. So let's take n equal to 2. Okay, A and B are 3 and 5. So what we are comparing? We are comparing 2 raised to 3 and 2 raised to 5. Which one is smaller? Which one is bigger?
Sir, 8 is smaller than 32.
8 is more than 32. So if A is less than B, n raised to A will be less than n raised to B. Okay? Is this okay to all?
Yes, sir.
Okay. Manan?
Yeah.
Okay. So these were some of the basic rules that I was trying to explain. We are always need to remember that when we add something, the inequality remains unchanged. If A was less than B, adding something on both the sides will not change the inequality. When we multiply, multiplying by a positive number will not change the inequality. Multiplying by a negative number will change the inequality from less than to greater than and vice versa. Similarly, when we divide, dividing by a positive number will not change the inequality, but dividing by a negative number will change the inequality. Okay? When we invert, the inequality also changes. So if A was less than B, 1 by A will become more than 1 by B. Okay? Even in negation, the inequality will change. In exponentiation, inequality will not change. They will remain unchanged. Okay?
Hey, Avnish, Shishir,
Yes.
what if n is negative?
That's a good question.
That's one part of it. And then we can continue further in exponentiation.
Yes.
And if
So,
A and B are whatever the relationship is, but they're on other sides of the zero.
yes. So, we have always talked about when both A and B are on the same sides. Okay. But
Okay.
we can, there can be cases when
Both are negative.
one is on negative side, one is on the positive side. Right?
Right. So I just wanted to push through all possible scenarios of positive
Yes.
and negative numbers.
Yes. So, let's maybe add a new sheet because this is getting too small. Okay. So, when A is less than 0 and B is more than 0. Okay. That means, let's take an example. When A is minus 2 and B is 2. So, and let A also be 2. That means not A, and equal to 2. So, what happens to A raised to minus 2 versus B, or instead of A, let's make it 2 raised to minus 2, and B is also 2. I think we'll need to make some different choices. So it becomes a little, so let's make it 3. So 3 raised to minus 2 and 3 raised to 2. And it's still positive. Now A and B are on the other sides. Which one is bigger?
Sir, the numbers will be 1 upon 9 and 9, and 9 is greater than 1 upon 9.
So if A and B are on the other sides, the relationship will remain unchanged, right? What if n is itself on the other side? So now let's take n equal to minus 3. What will happen?
Sir, still it
Minus
will
3
be 1 upon 9.
raised to minus 2 and minus 3 raised to 2. The reason why I avoided uh, the base as negative is because of such reason. This is a non-real number, or this is no, this is still not fractional, so it is a real number. what will this be
It
different?
will become 1 upon 9 and 9, right?
1 upon 9 and 9. That's correct. So the relationship is still true, isn't it? Minus 2 was less than 2.
But, suppose we put it as minus 3,
Mhm.
then 1 upon minus 1 upon 27 and
So
27.
let's
If
take
it is
upon minus 3. So n equal to minus 3, and a is equal to minus 3 as well. B is equal to 3. Okay. So what we are comparing? Minus 3 raised to minus 3 and minus 3 raised to 3. Which one is smaller? Right?
Yes.
Is this right? Is this one smaller or it's not smaller?
Sir, minus 1 upon 27 and minus 27.
So which one is smaller?
Uh, Sir, it will be, sir, it should be minus 27 lesser than minus 1 upon 27.
So the sign is right or wrong? The sign I gave here is right
Wrong,
or
sir.
wrong? This is wrong. Why? Because this side is, what are the comparisons? This is minus 1.27 and this side is minus 27. So this is bigger than this. So what happened? Why are we getting different numbers? Here it was okay and here it was not okay. Now how do we conclude? Can we conclude something?
Sir, exceptions.
No, but when we are trying to solve some problems, how many exceptions will you remember?
So
Getting my point?
what you are trying to ask the people is, what do they conclude in terms of what is the generalization they can make now?
Yes. Can we make a general rule here, which will just uh, keep with us while we're trying to solve problems?
Sir, if n, sorry, A and B are even or odd.
Yes. When I know both are even or both are odd, what should happen? But what if one is even, one is odd? We can get the conditions right. When A is even, B is odd. When A is odd, B is even, and all those combinations. So you need to just remember that when we are taking a even power for negative numbers, that becomes positive. Taking odd powers of negative numbers, that becomes negative. And instead of generalizing and remembering something, let's stick to the basics. That when we'll get a negative number, when we get a positive number. So this relationship that we have got here in exponentiation, let's keep it when n is positive. The base is positive. When the base becomes negative, the number of possibilities change. And in those cases, let's try to see what is the exponent now. Is a positive number, it's an odd number, it's an even number, and then take it to that level and then solve it. Don't use the generalized things to remember here when the base is negative, because the value of this exponent and the value of the base together will decide now which one is larger and which one is smaller. And there can be multiple cases as we have just seen here, right? Ishita, is it more confusing, or did you get what we are talking about?
Sir, it's quite confusing, but I got it.
What about Manan?
Yeah, I got it.
Sharia?
Yes, I got it.
Okay, so I'll not take too much problems here. Maybe I would ask you to try to take different values of n, a, and b, create a table, and see what all possible conditions you can get among all these three, and see if you understand them, when you will get the same inequality on exponentiation, and when the inequality will inverse, will change. Okay, so that's a homework. I'll ask you to try for all values of n, a, b between, let's say, -5 and +5.
Hello, Avnish. Should it be 3 instead of -3 here?
You mean in this
Next
problem?
slide. Next slide. This slide. Here. Yeah, where your cursor is.
Yeah, actually, this is the base I am taking is
Next
minus
line. Next line.
here,
Next line.
here.
Yeah. Yeah, here.
No, no, this is 3 only. This is -3 only.
Oh.
Okay, so what the task I'm asking for you is for all values of n, a, b in the set -5, -4, -3, -2, -1. I'll skip 0. I'll go to 1, 2, 3, 4, 5. Can you create a table and find when a is less than b, what happens to n raised to n, n raised to b? Did you got the homework?
Yes, sir. Yes.
Manan?
Yeah.
Okay.
Yes,
Shaurya?
sir.
No, I understood making the table with different values of N, A, and B,
Hmm.
but I did not understand the other part.
Okay. So you need to check when a is less than b, is n raised to a less than n raised to b, or the inverse. That means n raised to a is more than n raised to b.
Okay.
Ishita, you got the problem?
Yes, sir.
Okay. So try to do it in a methodical way on a piece of paper. Okay. Okay. So now let's go to solve a few problems using these basics. Okay. So we have 5x minus 3 is less than equal to 12, and x belongs to natural numbers. Can you try solving this? I'll give you a minute.
Sir, I understood
X
the
is
question.
less than or equal to 3.
What was that, Shaurya?
I said is X less than or equal to 3.
So what was? Can I take 2.5? That's less than 3.
No.
So what is the solution?
Sir, x can be between 1 to 3.
X can be 1, 2, and 3.
Yes, sir.
Good. Did everyone get that answer?
Yes, sir.
Okay. How did you solve this? Just
Sir, I tried first for the highest number possible, which will be lesser than or equal to 12, and
Mhm.
I got 3.
Okay.
And then since it is the highest possible, so every number below it will also be in the range. And x is natural, so it can only be 1, 2, and 3.
Okay. Let me also do the same thing what you people did, but I'll be using the same concept that we used in the previous page. So we had this inequation 5x minus 3 less than equal to 12. I am going to add 3 on both sides. This inequality will not change. Correct? So I can say 5x less than equal to 12 plus 3. I'm adding 3 on both the sides. This side it was minus 3 and I added 3 as well. I added 3 on both sides. This is okay.
Yes, sir.
So this plus 3 and minus 3 is gone. How do I format text strike through? So what it becomes? 5x less than 15.
5x less than equal to 15.
Now if I divide by 5 on both sides, because it's a positive number, the inequality will not change, isn't it? So what it says, x less than equal to 3. And we already know x belongs to n. That means x equal to 1, 2, and 3. Is this okay?
Yes, sir.
Yes, sir.
Manan?
Yes, sir.
Okay. So we solve it just like linear equations, but taking care that when we are dividing or multiplying, we need to make sure that if we are multiplying or dividing by a negative sign or a negative number, the inequality sign will change, which does not usually change for equality, because equality there is no difference whether you multiply by minus 3 or divide by minus 3, it will still remains unchanged. Okay, so this is the answer here. Now second problem is, I think I will inverse a little bit so that we make it like this. Can we solve this now? Can I remove these steps now?
Yes, sir. Sir, but I in the second question, you
Mhm.
have written minus 2x underscore plus
And
4.
there is no underscore. Let me delete it. So this was the solution for this. I'll just remove because I get more space then right here. Can we solve this now?
Sir, I get the answer to be equal to 0.
X equal to 0, you mean?
Yes, sir.
That's the only answer you get? Let's see. Anyone else got an answer?
I got x is greater than 0. All real numbers greater than 0.
All elements greater than 0. Okay, let's see. So we had 2x plus 4 less than 4, right? So if we subtract 4 from both the sides, we can remove this part, correct?
Yes.
Isn't it? And this also becomes 0 on this side. So 2x less than 0, we divide by minus 2 on both the sides. What will it become? Divide by 2. I should say, let's do it in the next step. So minus 2x divided by minus 2 and 0 divided by minus 2. What will be the sign now?
X.
The sign will change
Yes, X greater
because
than.
we are dividing by minus 2, right? So what it will become on the left hand side, x then 0. And since x belongs to a real number, all values greater than 0. How do you denote it on the number line? Let's go back to our number line and try to denote this on the number line. So when you are trying to denote on number line the inequality, what we do is we find the point. So this was 0. We do not color this point if it is greater than or less than. If equal to, we color that point. So we try to make this part bolder. This is the region that we're interested in, x greater than 0. If it was x greater than equal to 0, in that case we will make this dot a colored dot, and then the bold side will be on the positive side. You got the difference between equality and inequality? How to draw this on number line? One is a hollow 0, hollow point, and one is a solid point. Okay?
Yes, sir. Understood.
Okay. So that's how we draw it on the number line. Now let's go back and do you understand what is z?
Sir, integer.
That z is the set of integers. So what are the solution for this inequality? Can we solve this now?
X is equal to all integers greater than equal to 2.
Equal to
Yes,
2.
sir. Right.
Okay, let's see. So it becomes 3x minus 1 greater than equal to 5, and we can add plus 1 on both the sides. This will go away and it will become 3x greater than 6. We can divide by 2 on both the sides, right? Oh, sorry, 3 on both the sides, and then it becomes x greater than equal to 2. So the set becomes 2, 3, 4, 5, and so on. So how we write? X equal to 2, 3, 4, dot, dot, dot. 3 dots denote it's continued. Okay?
Yes.
Okay. So that was uh, the inequality on a number line when we have only one variable. How about when we get two variables? Can we solve this? Janil?
Sir, I am not sure. Sir, we could take y to the other side, so we will get x greater than 5 minus 5 y.
Anyone of you knows when you say x plus y equal to 5, what it shows? How do I think about it? This is an expression, right? Or equation.
Sir, we take different values for x and we get values for y. Like, for example, if we take x equal to 3, then we will get y equal to 2.
Right.
And so we go. We could do the same for inequality also.
Right. So, to since it has got more than one kind of values which are possible to satisfy this equation, let's try to do it on once again. This time on a graph paper. That means when we have two variables, one on the vertical axis, which is called y, and one on the horizontal axis, which we call as x. So when we say x plus y equal to 5, so let's write down here x plus y equal to 5. What does it denote? When y is or x is 0, what is the value of y? 5. When x is 1, what is the value of y? 4. Correct? When x is 2, value of y will be 3. So what we are getting? We are getting a straight line, right? On this line, wherever you go, you will find x plus y is equal to 5. Right? How about this point? This x equal to 5, y is 0.
Sir, when is going to be um, the workshop for the programming one? It's 4 o'clock.
Oh, okay. So I need to stop in that case. So
Vikalp has come, but just do a logical conclusion. I think so. 5 minutes we can take.
yes, so I think let's take one more
Yes, you
session
can
on this
continue. Yes.
inequality. No, we'll take one more session. We'll stop here right now, and we have some more things we want to talk about, and I don't want to kind of hurry up. So when we have more than one equality, that's also some conditions we need to think about. Okay, when x is not just one inequation, there's two